I am Ms. D. Lynette Sophia, working as Assistant Professor in Nirod Singandar Engineering College. This lecture is based on the topic Digital Image Processing Fundamentals. So, what is the digital image processing? So, this field of digital image processing refers to processing digital images by means of a digital computer. So, you have to know what is a digital image. So, a digital image can be defined as a two-dimensional function f of x comma y, where x and y are the spatial coordinates, and the amplitude of f at any pair of the coordinates x comma y is called the intensity or gray level of an image at that point. When this x comma y amplitude values of f are all finite and discrete quantities, we call the image as the digital image. So when we consider a digital image, it is composed of finite number of elements, each having a particular location and a value. So these elements are called as the picture elements, image elements, belts, and pixels. Pixel is the most commonly used term to denote the elements of a digital image. Application of digital image processing. Digital image processing finds various applications in various areas, like image sharpening and restoration, in medical fields, in remote sensing, transmission and encoding, mission and robotic visions, color processing, pattern recognition, video processing, and lot more. So, to process a digital image, we have certain fundamental steps. So, the first step is the image acquisition. So, image acquisition is getting the image from a source. After getting an image is acquired, we have to enhance the image called as image enhancement. After image enhancement, we have image restoration. Next is the color image processing, wavelets and multi-resolution processing, compression, morphological processing, segmentation, representation description, object recognition. So these are the basic fundamental steps to process the digital images. What is the image acquisition? Image acquisition is the action of retrieving an image from the source. It is the first step in the workflow sequence. So the first image, whatever we acquired, is completely unprocessed. So this is given to image enhancement stage where the images are adjusted. Adjusting the digital image is called as the image enhancement. So this is done by sharpening the image, increasing the brightness, and adjusting the contrast, removal of noise, etc. So by doing so, the image looks very pleasing to eyes. So it is always a subjective process. Next is the image restoration. So, image restoration is a process of recovering an image that has been degraded by some function and the additive noise. So, this is a objective process. Next is the color image processing. This part is going to handle the image processing of colored images either in indexed image or in the RGB images. So next, the spatial domain image will be converted to a frequency domain image by using a wavelets and multi-resolution processing. So wavelets are nothing but a small waves of limited duration which is used to calculate wavelet transform which provides time frequency information. This wavelets always leads to multi-resolution processing in which images are represented in various degrees of resolution. And next step is the compression. So compression is an important task in the digital image processing where you can reduce the storage space to save an image and bandwidth required to transmit it. Next is the morphological processing. So this deals with extracting image components that is useful for representation and description of an image. It includes morphological operations like erosion and dilation. And as we seen in the block diagram, the morphological processings are usually the image attributes, where you will be using the outputs of the outputs, whatever we get after the morphological processing, are only the image attributes. Segmentation. This process is partitioning the digital image into multiple segments to locate its objects and the boundaries in an objects. Next step is the representation and description. So representation deals with covering the data into suitable form of a computer processing. So you have two types of representation, boundary representation and regional representations. And last step is the recognition. This is the process of assigning a label to an object based on its description. And a knowledge base. So knowledge about a problem domain is coded into an image processing in the form of a knowledge database. So even though the digital image processing involves mathematical calculations, human interventions, and human structure of a human eye is a basic step in analyzing or taking steps in digital image processing methods. So the structure of a human eye looks like this. So it has a eye is nearly a sphere with an average diameter of approximately 20 millimeter. The three membranes are enclosed in the eye. One is the cornea, sclera, outer cover, the choroid, and the retina. The cornea, first we'll see about the cornea. The cornea is a tough, transparent tissue that covers the anterior surface of the eye. Continuous with the cornea, the sclera is opaque membrane that encloses the remainder of the optic lobe. Next is the choroid. The choroid lies directly below the sclera. This membrane contains a network of blood vessels that serves as a major source of nutrition to the eye. The choroid coat is heavily pigmented and hence which reduces the amount of extraneous light entering into the sky eye and the backscatter within the optical globe. At the anterior extreme of the choroid is divided into two parts. One is the ciliary body and next is the iris diaphragm. The, the iris diaphragm contracts or expands to control the amount of light that enters into the eye. The front of the iris contains the visible pigment of the eye, where the back contains the back pigment. And an important part of the eye is the lens, which is made up of concentric layers of fibrous cells and is suspended by fibers that attach to the ciliary body. So this contains 60 to 70% of water, about 6% of fat, and more protein than any other tissues in the eye. Next is the retina. The innermost membrane of the eye is the retina, which lies inside wall of the entire and posterior portion. When the eye is properly focused, light from an object outside the eye is imaged on the retina. Pattern vision is afforded by the distribution of discrete light receptors over the surface of the retina. There are two classes of receptors, one is cones and rods. The cones in each eye numbers between 6 to 7 millions. They are located in the central portion of the retina called the fovea and are very sensitive to color. Muscles controlling the eye rotate the ball until the image of an object of interest falls on the fovea. The cone vision is called the photopic or bright light vision, and the rod vision is called as a scotopic or dim light visions. The number of rods is much larger, so it has 75 to 115 millions distributed over the entire retinal surface. So this figure depicts the number of rods and cones of the cross section of the eye passing through a region of emergence of the optic nerve from the eye. The place where the no rods and cones are present are called as the blind spot. So the absence of receptors in areas called as the blind spot. So we can see that cones are most dense at the center of the retina called the fovea. And the distance between the center of the lens and the retina is called the focal length, which varies about 17 mm to about 14 mm. When the eye focuses on the object farther away, the lens exhibits its lowest refractive power. When the eye focuses on a nearby object, the lens is most strongly refractive. For example, when an observer is looking at a tree at 15-meter high at a distance of 100 meters, now considering h is the height and h is the height in mm, and the height is given by 15 by 100 is equal to h by 17, or h is equal to 2.55 meters millimeters. Light and electromagnetic spectrum. So Isaac Newton discovered that when a beam of light is passing through a glass prism, the emerging beam of light is not a white, but is a continuous spectrum ranging from violet to other colors. So when you consider a simple image formation model, it images are formed by, as we said in the from the starting, images are formed by a two-dimensional function of f of x comma y, where this x and y are the spatial coordinates and intensity of the image and gives the intensity of the image at that point. As light is in the form of energy, f of x must be non-zero and should be a finite one. It is characterized by two components. One is the illumination and another is the reflectance. The source amount of source illumination incident of the scene is being viewed, and the amount of illumination reflected by the objects in the scene, that is called as the illumination, and the reflectance, which is denoted by I of x comma y and the reflectance R of x comma y. So these two functions combine to form an entire image f of x comma y. So totally the f of x comma y is nothing but the multiplication of your reflectance and the illumination I of x comma y and the R of x comma y. So the intensity of the monochrome of the image f at any coordinate x comma y of the gray level L at the point is given by I is equal to f of x naught comma y naught, and L lies in the range L minimum to L maximum. The intensity L is given by L minimum to L maximum, and the intensity is given by f of x naught comma y naught. And the interval between this L minimum to L maximum is called as the grayscale. Grayscale, where L is 0, it is considered as black. When L is equal to L minus 1, it is considered as white on the grayscale. All the intermediate values are shades of gray varying from black and white. So when considering the relationship between, so the entire image, the image is now formed of lot of pixels. So there should be a relationship between the pixels. So we'll see what are the relationship between the two pixels f of x comma y and f of x comma x, next pixel f of x plus 1 and y plus 1. So first one is the neighbor of a pixel. A pixel p at coordinate x comma y has four horizontal and vertical neighbors whose coordinates are given by x plus 1 comma y, x minus 1 comma y, x comma y plus 1 and x comma y minus 1. So has four horizontal and vertical neighbors is called as the, these pixels are called as the neighbors. Thus, this set of pixels called the four neighbors of P, it is denoted by n4 of P. Each pixel is a unit distance from x comma y, and sum of the neighbor of P lying outside the digital image if x comma y is in the border of the image. And we have as n4 of p, neighbor of a pixel, we have ndp, nd of p and n8 of p. Nd of p is nothing but the diagonal neighbors. Coordinates are x plus 1 comma y plus 1, x plus 1 comma y minus 1, x minus 1 comma y plus 1, x minus 1 comma y minus 1. So these four diagonal neighbors are called as the nd of p. These points, this NT of P, together with the four neighbors N4 of P, totally forms the N8 of P. If some points in the NT of P and N8 of P fall outside the image of x comma y is on the border of the image. Apart from neighbors like N4 of P, N diagonal of P and N8 of P, we have adjacency, connectivity, regions and boundaries. To establish whether two pixels are connected or not, it is determined that if they are neighbors. If the gray levels satisfy a specific criterion of similarity, say if the gray levels are equal, for instance, for example, in the binary image with values 0 and 1, two pixels may be four neighbors, but they said to be connected only if they have same value. This is called as boundaries. We have three types of adjacencies: 4 adjacencies, 8 adjacency, and M adjacency. When there is a 4 adjacency, two pixels P and Q with value from V are 4 adjacent if Q is in set N4 of P. 8 adjacency, two pixels P and Q with values V are 8 adjacent if Q is in N8 of P. M adjacency means it is the intersection of N4 of P and N8 of P. Two pixels P and Q with values from V are M adjacent if Q is in N4 of P or Q is in NT of P. So, apart from pixel P with coordinates x comma y to pixel Q with coordinate x comma t is a sequence of distinct pixels with coordinate x naught, y naught, x1, y1 till xn, yn. Two pixels are said to be connected in S if there exists a path between them consisting entirely of pixel in S. Thank you.